Hello, and welcome to this demo. We are going through the Kubernetes Certification course, and in this demo, we will look at the solution for the practice test on ReplicaSets. Now, this is a beginner's level test, so we will see how to solve the challenges. So first, go to the link for taking the practice test. When you're ready, click on Start Scenario. And this is the terminal where you'll be working. Click on Quiz Portal to open up the portal. Okay, so you have about an hour to go through about 15 questions. Now these are all very simple questions. So to start with, we'll go through some of the information gathering questions like read the environment, inspect the environment, and understand the number of pods, replica sets that are available, look at the existing replica sets and try and figure out information from that, troubleshoot issues with replica sets and try and fix them, as well as creating your own replica sets. So let's get started. So the first question is, how many pods exist on the system? And all operations are done in the current or the default namespace, so you don't have to change the namespace. So let's go back to the console and we'll try to figure out how many pods exist. So I'm going to run kubectl get pods command. So there are no resources found, so the answer is 0. The next question is, how many replica sets exist on the system? So I'm going to run the kubectl get replica sets command. And so there are no resources found. So that's the answer is 0. Okay, so some changes were made. So how about now? How many replica sets do you see? So let's go back and run the command again. And we see that there's one replica set created. So let's select 1. Okay. How many pods are desired in the new replica set? So if you go back and look at the output of the command that we just ran, the desired column says 4. So that means that there are 4 pods desired for this replica set. So the answer is 4. What is the image used to create the pods in the new replica set? So there are a number of options given, and we need to find out what the image is on the replica set or on the pods. So for this, we can run the command kubectl describe replica set, and it prints out the detailed information regarding the replica set. If you look under containers, under the pod template, under containers, the busybox container, there's only one container in each pod, and the image used is busybox 777. So that's the answer. It's busybox 777. How many pods are ready in the new replica set? So again, if you go back and look at the output of the command we ran earlier, the ready column says 0. So that's the answer. None of the pods are ready. So we could also run it again. We could also run the command again just to see if it's updated. Nope. So the answer is still 0. So let's go back and select 0. So why do you think that the pods are not ready? So let's go back and see, let's try and troubleshoot and see why it's not ready. So if you go back and look into the output of the kubectl describe replica set command, you can see that 4 pods or 4 replicas are desired, and all 4 are in a waiting state. None of them are succeeded, or none of them are running. If you look under the events here, you see that all 4 pods were created. You do not see anything further. So let's dig in and look at the state of the pods. So I'm going to run the first, let me clear the screen. Okay, I'm going to run the kubectl get pods command, and I see that there are 4 pods, and they all have the name of the replica set as a prefix. The status is image pull back off. Now, if you're not sure what that means, we can actually dig in further and look inside one of the pod. So kubectl describe pod, and then I'm going to type in the name of one of the pods, new replica set 62MB2. And now if you look under the events, you see that the different events. So it's trying to pull the image busybox777, failed to pull the image busybox777, and the actual error towards the end is repository busybox777 not found, does not exist, or no pull access. So that tells us that the repository, the image busybox777, does not exist on Docker, and that's the reason why it's not able to pull the image. That's the reason why the pods are not running. So it's not the first one. The second one that says the image busybox777 doesn't exist. So that's the correct answer to this question. Okay, next, delete any one of the 4 pods. So let's go back to the terminal and let's first clear the screen. We'll say kubectl get pods command, and we will run the kubectl delete pod, and then we'll use one of the pod names. So we're going to try and delete the first pod. We'll wait for the prompt to come back. Okay, so the pod is deleted. Click done. How many pods exist now? So let's go back and run the get pods command again to see how many pods exist. Okay, so we can see that there are still 4 pods, 1, 2, 3, and 4. And earlier too there were 4 pods. Even though we deleted, there are still 4 pods. So the answer is 4. So why are there still 4 pods even after you deleted one? So the answer is not because I didn't delete it properly. I did delete it, and it did say that the pod is deleted. You cannot delete a pod from a replica set. That's not true either, because we were able to delete the pod from the replica set. The third one that says replica set ensures that desired number of pods always exist. So that's the right answer. So the purpose of a replica set is to ensure that a given number of pods always exist. So even if you manually delete any of these pods, or if any of the pods were to get deleted, or due to a program being terminated or an error inside the image or the application, and if the pod were to get deleted automatically, replica set will fire up a new pod to ensure that the desired number of pods always exist. So that's the right answer. Okay, now getting into a little bit of YAML file, replica set configuration and troubleshooting. Create a replica set using the ReplicaSet definition-1.yaml file located at root. So let's look at, so the current directory is root. So let's list the files here. So this is the file that the question is referring to, ReplicaSet definition-1.yaml. So the task is to create the replica set using this definition file. So we can take a look at the file real quick. ReplicaSet definition-1.yaml, and that's the definition. So let's just let's first try to create the replica set. Create -f ReplicaSet definition-1.yaml. Okay, so that has failed. It says unable to recognize ReplicaSet definition YAML file. No matches for kind ReplicaSet in version 1. Now, the purpose of this exercise, or these kinds of troubleshooting exercises, is to make you comfortable working with YAML files and definition files. You will very often come across such errors in real life while working with Kubernetes, or if you're actually giving the Kubernetes certification exam, you'll come across a lot of such errors, and you need to know what these error messages mean. You must be able to look into the error messages, read them, understand them, and know exactly what that means and how to fix it. And that's the whole purpose of these kinds of exercises. Okay, so if you look at the error message in this case, it says no matches for kind replica set in version v1. So it's actually talking about the first two lines in our replica set definition file. This particular version, which is v1, has no match for replica set. So it's either a problem with this or a problem with this. Sometimes when you give the case of this kind incorrectly, you will come across the same error message. So you need to know you need to know what that is. Now you don't have to memorize what is here and what is here. You can always refer to the documentation site in such cases. So go to the Kubernetes documentation site at kubernetes.io/docs and search for ReplicaSet. So in the search bar, and from the result, I usually go with the first outcome. And if you just scroll down here, you should be able to see a sample definition file. What we are concerned about is the first two lines. As you can see, it's not v1, it's apps v1, and replica set is correct. So this is the issue. So let's go and change that. So I'm going to update the replica set definition file, and right here I'm going to add the apps part. I will save the file and I will create it again. Okay, so that's successful and the file is created. Let's go back and check our work. Okay, so that's successful. The next task is to fix the issue in the ReplicaSet definition-2.yaml file and create a replica set using that. So let's try that right now. I will directly try to create the replica set using the definition file. That's kube control create -f replica set definition2.yaml. Okay, so this has failed again, and it says this time that invalid value selector does not match template labels. So let's take a look at the file ReplicaSet definition2.yaml, and if you look in here, you see that so the error message is selector does not match template labels. So the selector is this selector that it's talking about. So this has a selector with match labels of tier front end, and it is trying to match this with the labels defined here. And so the issue here is that this label tier front end does not match this label, which is tier nginx. So when the replica set is created, Kubernetes first tries to create a template, a pod, or the required number of pods using this particular template. So everything under here is a pod definition. Everything under template is a pod definition. And it tries to create that, and then it tries to create the replica set and link the replica set with these pods. And in order to do that, these two must match, and that's why it's important that these two are the same. Otherwise, the replica set will not have any pods under it. So this is what links the replica set and the pods to each other, and they should always match, and that's the check that is being performed here before even Kubernetes tries to create these objects. So in this case, we either need to use front end in both places, or use nginx in both the places. So it doesn't really matter what you use. You just need to fix the error and get the replica set created. So in this case, I'm just going to update the label here to match whatever is given up. now try to create the replica set again. Okay, and it's successful. I will go back and check. Okay, now while we are there, I just wanted to give a quick tip, especially for the certification. So if you're attempting the certification, your work is not validated like this. So in that case, you need to make sure that whatever you've done is working and is correct. So for example, if you are asked to create a replica set named ReplicaSet2 with this particular labels and this particular image for the pod, you need to do a quick check of your work to ensure that you've done it correctly. Even if you're successful in creating the replica set, you must ensure that you used the right information. So I believe exam evaluation is automated. I don't know how, but it could be, or it should be automated. So if that is the case, then these whatever tasks you're asked to do may be checked automatically, and so it will have to match exactly. So if you're asked to use nginx image, you have to use nginx image, and for that it's best you do a quick check of your work after you do something. So in this case, it's best you check your replica set by running a kubectl get rs command and make sure that okay, it's named as ReplicaSet-2, and also do a quick check like this, kubectl describe rs is a short for replica set, and that'll come handy in the exam, especially when you're time constrained. And it's good to make sure that the image that was asked to use, the labels that are asked to use are the same. So that's a quick tip. Okay, so the next task is to delete the two newly created replica sets. So you could do a kubectl delete, and I'm going to use the short form for replica set going forward, rs, and then the replica set -1, replica set -2. Okay, so they are deleted. Click on check. That is successful. Now the next task is to fix the original replica set new-replica set to use the correct busybox image. So remember earlier we identified that the pods were not starting due to the image, which was wrong, which was busybox 777. So it has to be updated to busybox. So let's go and try to do that. Now, whenever you're asked to update an existing object, the first thing that comes to your mind is probably to use the kubectl edit replica set command and then specify the name of the replica set, which is new replica set. And when you do this, for most of the objects in Kubernetes, it opens up a definition file for that object in a VI editor, and you can make changes to that object from here. So in this case, I'm just going to make a change to the image name. It's busybox 777. I'm going to get rid of the 777 from here and then save the file. Okay, so it says the replica set is now edited. Now let us see the state of the replica set. kubectl get replica set. As you can see, it's still in the same state. There are still no pods that are ready. If you look at the state of the pods, you see that they're still in that error state. If you further look at the one of the pods in detail, let's say the first one, you see that it's still in the image pullback off state, and it's still using the old image, which was busybox 777, but we actually updated the image name. Now the reason for that is the replica set, even if you edit an existing replica set, it does not carry forward those changes to the existing pods. Only when a pod is deleted and a new pod is created, the changes are applied. So it does not automatically apply the changes in the containers for the existing pods. So we have two options. We can either delete each pod one by one and then have replica set automatically create new pods, or we could delete the replica set itself and create a new replica set. So let's try the first option, get get pods. And as you can see, let's try and delete one. Delete pod, the first one. We'll wait for that to get okay. That's deleted. When I now run the get pods command, it's created a new pod and it's actually running. So that's one of my options. So I can also go ahead and delete all the others. Let's now just look at the other method as well, just so you're aware. Okay, so the other method is to delete the replica set. But before deleting, remember, if I delete this replica set right now, I do not have the definition file for it. So it was already there. It was automatically created when I came into this environment. So I do not have a definition file for this existing replica set. So if I delete it, I may not be able to recreate it. Now, anytime you're in that scenario where you do not have the definition file for any objects in Kubernetes and you want to capture it or create it, instead of looking at the properties and creating a definition file yourself from scratch, you could simply export the definition file out of Kubernetes. So if you run a kubectl get replica set command with the name of the replica set, okay, it lists the replica set information. What I'm going to do is you could use the -o option along with the YAML option to get the definition of the replica set in a YAML format, and that's what we can use to edit or to save the configuration. Okay, so when I run that command when I run the kubectl get rs command with the -o YAML option, I get the definition file for the replica set. Now this was not created by me, it was never there, so this was automatically generated by Kubernetes for me. Now there's a lot of information in this which we can delete. For example, the creation timestamp, these UIDs and links, etc. Or we can just leave it there too. It doesn't really matter. So I'm going to save those contents into my own definition file. I will name that new replica set.yaml. Okay, now I can safely delete my replica set. So I'm going to do a get kubectl delete rs new replica set. Okay, that's deleted. I can now create the new replica set by running the kubectl create -f new replica set.yaml file. Okay, the new replica set is created. And run get rs. It's creating the new replica set. Okay, there are 2 pods ready. There are 3 ready. There are 4 ready. I run the get pods command. I can see that there are 4 pods ready. There's still 1 pod that's left off of the previous replica set, but it should be gone anytime. Okay, that's gone. Okay, perfect. So let me check the work. Okay, that's successful. The next task is to scale the replica set to 5 pods For this, we can use the kubectl scale command, or we can edit the existing replica set using the kubectl edit command. So in this case, we will use the scale command, kubectl scale replica set new dash replica dash set dash replicas equals 5. Okay, it says it's scaled. When I run the get rs command, I see that the desired number is 5. When I run it again, I see that there are 5 that are ready. So if you look at the pods, you will see that there's another additional pod that was just created. Okay, the same way you can scale the replica set down as well to 2 pods. So I'm going to run the same command to scale it down to 2. Check the number of pods. As you can see, there are 3 terminating, and there are 2. The desired and current and ready count is now 2. Check the work. Okay, so that's the end of it. So that's a really easy lab, but we're also working on building advanced labs. So going forward in the upcoming exercises, the difficulty should go up a little bit. At the end of all of the exercises and all of the topics that you're going to go through, so we have a lot of labs coming up for configuration, multi-container pods, observability, pod design, services and networking, state persistence. And after all of that, we're going to have a series of challenges which are going to be a bit more challenging with a bit more difficulty level. So you'll be given an architecture and you'll be asked to create the Kubernetes configuration to set up the actual Kubernetes objects to solve that architecture or to build that architecture out. So that should be more fun. Well, thank you so much for your time. Go ahead and give the exercises a shot yourself. I will see you in the next lecture.